Okay, so now I'm gonna turn on the system from 0 to show you all the detailed functions. Okay. First, this is the power unit we already know, right? And here it has a small button that you push this button. And you can see this here is the smart breaker is detecting the power grid. The power from power grid is normal or abnormal. Because we have to understand that when you deploy the cabinet in outdoor environment, you will face a lot of challenge first from power grid. We know that many countries, like developing countries, their power grid is not that stable. You will facing some challenge of over voltage, under voltage, over current, and sometimes probably when the people is operating the cabinet, you will face some like a short current things, right? Short circuit, sorry. So the breaker will help you to protect the system from this kind of challenge. On the other hand, you will face another thing is lightning. You know, in outdoor, the lightning, if you don't consider very well, the system will be easily destroyed by the surge. So the smart breaker here has to function is first to protect your system from the challenge from the power grid. On the other hand, protect the system from the surge, from the lightning. Then here is a test button. We can test manually, see the power grid that is normal or not. Here is the battery button. So you see that because it's a UPS system, right? So if it is a UPS system, you turn off the power grid, actually you still will the system will running based on the battery. So how to turn off the 100% of the system is to push the button. Let's see. Okay, if I turn off this button, so the input power disappeared, right? So you can see that right now the system is running based on the battery. Now if we turn off this button, not really, the whole system shut down, right? Okay, let's turn it on again. Okay, so you can see that at the beginning the monitor unit actually is detecting the whole devices. It's a self-check. The fan system right now at the beginning running a little bit, right, then turn off. Later it will turn on again. Is because it's in the self-check process. And here I want to say is this here we have a LED light, right? Because we learn a lot from the outdoor deployment. Really, sometimes engineer has to work at night, right? So if they work at night, you don't have any, let's say, a light or something will be not very convenient. So, but on the other hand, if you turn on the light all the time, it will waste the power, right? So the light actually is controlled by the door sensor. This is a door sensor, okay? The door sensor, because if you close the door sensor will detect it. For example, if I push the door sensor, you see that? You see actually the system already detected the door is closed, right? So the light is off. Then I put it back, the lights turn on again. Then another thing I want to explain is, you see here is the device slot, right? You can find that we have some small cable here. What's the function of the cable? Actually, it's this project, our customer asked us to provide a DC12, DC24, and DC48 because they have some switch and roller disconnect devices. What we provide is directly feed this kind of power cable to their devices, because we see every time to do the project, we will talk to you to understand what kind of device you want to put in. Then we will know that what kind of power it needs and what kind of interface it is, right? So we can prepare the cable in advance for you. And this kind of a cable finally is connected to the SPB slot from the back. So you don't worry about the cabling. So when you receive the cabinet, what you need to do is really plug and play. You see, you put the power in, then turn on the system, and the system running. You put your devices here and connect to the cable. That's it. Here has another topic is I want to emphasize is we don't really recommend you use use different kind of power adapter, because from the normal understanding, people will use an AC UPS, then use a power adapter, then connect to the devices, something like this. It's totally not necessary. there's a lot of weakness. First, this kind of power adapter is the device is not very reliable. Its MTBF cannot compare with the whole system, you know. So in the end, it's the weakness of your system. 2 or 3 years later, probably the power adapter is broken, then your whole system is down. You have to change it. Remember, our site is in rural area. That's costful. On the other hand, because you see that normal system, if you put an AC DC UPS here, AC UPS here, you have to, how to say, the system have to AC power go to AC UPS, and AC UPS charge the DC battery get the power out, and then turn the power become AC again, which has a small inverter inside, right? Then come out and then feed to your devices. Power adapter changes AC to DC again, you know, then feed to the devices. You lose a lot of power here. Let's say not a lot, but efficiency is not that high, right? So why we design a system like this? It's because previously we understand that most of our customers understand that in the market this is their only choice. But hey, we're telling you that you have other choice here. You have a plug-and-play system. You have some people sit with you to design the power interface here. So why not sit with us to design together, right? To make the system much more simple. All right, so this is like the system's running. So next step, I want to introduce a little bit about the detailed software functions. So please see next part, okay?